Have you ever wondered how a self-driving car sees a stop sign, or how FaceID recognizes you even when you're wearing glasses? The answer lies in a specific type of deep learning algorithm called a CNN, or Convolutional Neural Network. Hello everyone. In today's session, we are going to demystify CNNs. We will look at what they are, the architecture behind them, and exactly how they process images differently than standard networks. Let's dive in. First, why do we need CNNs? Why can't we just use a standard artificial neural network? Well, imagine you have a picture of a smiley face. A standard network sees this image as a flat list of numbers. It destroys the spatial structure. It doesn't know that the left eye is next to the right eye. A CNN is different. It treats the image like a grid. It understands that the relationship between neighboring pixels matters. It preserves the shape and structure of the object. Think of a CNN like a detective analyzing a crime scene photo. The detective doesn't look at the whole photo at once. Instead, they use a magnifying glass to scan it, piece by piece, looking for specific clues, like a fingerprint or a footprint. In deep learning, this magnifying glass is called a filter or a kernel. A CNN is built like a sandwich with three main layers. Let's break them down. First is the convolutional layer. This is the feature extractor. We slide a filter over the image to perform a mathematical operation called convolution. Early layers detect simple things, like vertical lines or edges. Deeper layers combine these to find eyes, ears, or wheels. Next is the pooling layer. This is the summarizer. It shrinks the image size to reduce computing power. Usually, we use max pooling. It looks at a small area and just keeps the highest number, the most important feature, and throws away the noise. Finally, we have the fully connected layer. Once we've detected all the features, like pointy ears and whiskers, we flatten that data and feed it into a standard network to make the final decision. Is it a cat or a dog? Let's look at a real example. Imagine we want the AI to recognize a handwritten letter X. When the CNN scans this image, one filter lights up when it sees a diagonal line going right. Another filter lights up when it sees a diagonal line going left. In the deeper layers, the network realizes, hey, I have a right diagonal crossing a left diagonal. The fully connected layer takes this summary and predicts with high confidence. This is an X. CNNs are powerful. We use them in medical imaging to detect tumors, in self-driving cars to detect lanes, and in social media to auto-tag your friends in photos. That is the power of convolutional neural networks, the algorithm that gave computers the ability to see. If you found this explanation helpful, please hit that like button and subscribe for more deep learning tutorials. If you want to see the Python code for this, let me know in the comments. See you in the next video.